F-8 Tomahawk cruise missiles, 3 carrier strike groups, 40 surface combatants, over 13,000 confirmed military targets destroyed across the Iranian coast, the island positions, the radar arrays, the command nodes. 30 days of the most sustained naval strike campaign since the Second World War, and on day 31, the Strait of Hormuz was still closed. That number should not exist. Not after that volume of ordnance, not after that level of commitment. If you watch the coverage, you probably assumed the strait would open. The firepower was overwhelming. The carrier presence was undeniable. The sortie count was historic. And yet nothing moved through those 21 miles. So on March 27th, something changed. Not more missiles. Not a fourth carrier group. The USS Tripoli arrived in the Central Command area of operations carrying 3,500 sailors and Marines, with F-35Bs on the flight deck. Behind her, the USS Boxer was transiting with 2,100 more. Over 5,000 Marines converging on the narrowest, most consequential chokepoint on Earth. Iran's parliament speaker responded within 48 hours. Iranian forces are prepared to confront any American troops who set foot on Iranian soil. The surface reading is simple. Marines are coming. Iran is scared. Invasion is imminent. That reading is wrong. The right frame is not about invasion. It is about geometry. And to understand what 5,000 Marines actually change about this equation, you first have to understand why 850 missiles change almost nothing. The Strait of Hormuz is 21 nautical miles at its narrowest point. 1/3 of the world's liquefied natural gas moves through it. Roughly 20 to 21 million barrels of oil transit daily at normal operating tempo. 6 of the world's largest economies depend on that flow to function. When it closes, energy markets react within hours. When it stays closed for 30 days, the downstream effects reach into supply chains, food logistics, and industrial output on 4 continents. This is not a regional dispute. It is a pressure valve on the global economy, and Iran holds the handle. The United States Navy has known this for decades. CENTCOM has war-gamed Hormuz closure scenarios since the 1980s. Every carrier strike group that transits the Persian Gulf does so with Hormuz contingency planning embedded in its operational orders. The U.S. has more experience thinking about this strait than any military institution in history, and yet, 30 days in, it was still closed. That is the contradiction that forces the real question. Not, will Marines invade Iran, but why did the Navy, with all of its strike capacity, reach the limit of what maritime power alone can accomplish? The answer lives inside how Iran actually built its denial system. Iran does not defend the strait the way the United States Navy was built to fight. This is critical. The U.S. Navy was designed, funded, and optimized to defeat a peer naval force, blue water adversaries, surface combatants, submarine fleets, carrier groups against carrier groups. That entire architecture, the Aegis radar systems, the long-range anti-ship missiles, the carrier air wings, was built for a mirror image fight. Iran does not offer a mirror image. What Iran built instead is a layered, asymmetric, geographically embedded denial system. It has 3 interlocking components, and destroying any one of them does not collapse the others. The first layer is mobile anti-ship missile batteries. Iran operates a significant inventory of domestically produced anti-ship missiles, derivatives of Chinese and Russian designs, upgraded over 2 decades of sanctions-era engineering. They are mobile. They are dispersed across the Zagros foothills, the coastal ridgelines, and hardened tunnel networks carved into the Iranian interior. Destroying a battery requires knowing where it is within a window narrow enough to act. They move, they hide, they reappear. The second layer is the fast mode swarm. Iran's Islamic Revolutionary Guard Corps Navy operates hundreds of small, high-speed surface craft armed with rockets, torpedoes, and machine gun systems. Individually, they are not threats to a carrier. Collectively, swarming a choke point in shallow littoral water, they create a mine-laying, harassment, and targeting coordination capability that exhausts defensive systems not designed for volume. The Navy can kill fast boats. The question is the cost ratio. Shooting a Tomahawk at a speedboat is not a sustainable exchange. The third layer, the one that actually closes the strait, is the mining capability. Iran has one of the largest naval mine inventories in the region. These are not sophisticated systems. Sophistication is not the point. The point is that a mine does not require a radar signature, does not emit, does not move, and costs almost nothing to deploy. A single mine closing a shipping lane forces the entire transit to halt until that lane is cleared. Mine countermeasure operations are slow, they are dangerous, and they require ships to operate in exactly the kind of confined, shallow water where Iran's other layers are strongest. You can kill missiles. You can sink fast boats. You cannot bomb a minefield into submission. This is the architecture the Navy has been fighting for 30 days. And this is why the numbers don't match the outcome. Here is where the math becomes uncomfortable. The Navy destroyed more than 13,000 targets. That is not a small number. By any historical comparison, that sortie count would have dismantled a conventional military force many times Iran's size. But Iran's denial system was not built to absorb that kind of attrition and remain intact. It was built to remain functional with pieces missing. Think of it this way. A conventional military collapses when you destroy its command and control, its logistics nodes, its air defense, and its armored formations. Those are load-bearing structures. Remove them and the system fails. Iran's Hormuz denial architecture does not have those load-bearing structures. It has redundancy by design. Lose 10 missile batteries. 30 more are positioned in terrain the Navy cannot reliably surveil. Lose 100 fast boats. The IRGCN still has the mass to complicate transit. The mines are already in the water. The Navy's problem is not firepower. It is that the system it is fighting was specifically designed to absorb firepower without losing function. Every dollar spent on a Tomahawk strike against a mobile launcher that moved 2 hours earlier is a dollar that did not advance the operational objective. This is not a criticism of the Navy. It is a description of a designed mismatch, one that Iran engineered deliberately over 30 years of studying U.S. strike doctrine. So if the Navy alone cannot crack this system, what changes when Marines arrive? The answer is not invasion. The answer is not invasion. Iran's layered denial system works because all three components operate from a fixed geographic relationship to the strait. The missile batteries sit on the high ground to the north and east. The fast boats stage from coastal inlets and hardened shelters along the Iranian shoreline. The mines are distributed across the transit lanes from positions Iran controls. Every element of that system faces the water. It was built to face the water. The threat model that Iran planned around for decades comes from the sea: carrier-based aircraft, cruise missiles, naval surface fire. The entire system is oriented seaward. A marine amphibious force does not come from the sea in the way Iran planned for. What 5,000 Marines aboard 2 amphibious assault ships represent is not a single landing point. It is a movable problem. The Tripoli and the Boxer are not committed to a specific beach until they choose to be. That uncertainty forces Iranian planners to account for multiple potential landing zones simultaneously. The Qashm Island complex, the Larak Island approaches, the coastal terrain around Bandar Abbas. Each of those represents a viable amphibious axis. Each one, if seized or suppressed, changes what Iran can do from that position. Iran cannot defend all of them simultaneously with the same force density it uses to defend the strait from seaward attack. This is the geometry shift. The Marines do not need to invade Iran. They need to exist as a credible threat at multiple locations simultaneously. That threat forces Iranian commanders to make a choice. No defensive system handles well. Do you thin your coastal defense to cover all potential landing zones, or do you concentrate and accept exposure elsewhere? There is no clean answer. That is the point. Now look at what the F-35Bs add to this equation. The USS Tripoli is not a traditional amphibious ship in a traditional role. She is operating F-35Bs, the short takeoff, vertical landing variant of the Joint Strike Fighter. The F-35B is not primarily a strike aircraft in this context. It is a sensor node. The F-35B's radar and sensor fusion architecture gives it the ability to detect and track mobile missile launchers that ground-based surveillance struggles to fix. It can do this while remaining largely invisible to the radar systems Iran uses to cue its air defense. What that means operationally is that the cat-and-mouse problem, finding mobile launchers before they move, changes its character when F-35Bs are in the area. The window between detection and strike shortens. The cost of mobility increases for Iranian forces because they can no longer rely on radar emission patterns to anticipate when they've been found. The F-35B also provides the Marines with organic close air support during any landing operation. That integration, shipborne Marines supported by F-35Bs from the same deck, is a combined arms package that Iran's coastal defense planners have not faced in this configuration before. And there's a third effect, quieter than the others. F-35Bs operating near the strait increase the survivability of the Navy's own surface combatants by building a more complete picture of what is in the water and on the coastline. Better data means better targeting. Better targeting means fewer sorties wasted against empty positions. The Marines and the F-35Bs are not a second attempt at the same solution. They are a different kind of pressure, applied to a different dimension of the problem. Consider the strategic consequence of that pressure shift. Before the Tripoli arrived, Iran's strategic calculus was functioning as designed. The Navy was paying a high cost-per-effect ratio, fighting a system built to absorb naval strike power. Time was working in Iran's favor. Every week, the strait remained closed. Economic pressure accumulated on U.S. partners and allies. Every week without a decisive breakthrough raised questions about the limits of American military power. That calculus depended on Iran being able to concentrate its defensive effort in a single dimension, the maritime approach. Remove that concentration by introducing a credible amphibious threat, and the calculus shifts. Now Iran must fund its coastal defense budget across multiple dimensions simultaneously. Forces previously dedicated to straighten the Nile must be repositioned or at minimum held in reserve against the landing. That repositioning is not invisible. It creates signatures. It creates windows. The Marines do not need to fire a single shot to change what the Navy can do in the strait. The credible threat of their landing creates the condition that makes Iran's layered defense less coherent. And a less coherent defense is one that strike aircraft can begin to systematically dismantle, not by flying more sorties at the same targets, but by catching forces in transition, exposed, unable to hold their optimized positions. This is what combined arms means at the operational level. Not tanks and infantry working together in a field. Two different pressure vectors forcing an adversary into a position where their system cannot function the way it was designed. Iran built a fortress facing the sea. The Marines are not trying to knock down the front gate. They are appearing at the side walls, and the act of appearing is enough to begin pulling the garrison apart. 30 days from now, the situation in the strait may look very different. Not because of a single dramatic strike, not because of a decisive amphibious landing, but because the geometry of the problem has changed in a way Iran's planners cannot simply adapt around. The layered denial system works when the threat is predictable. The Navy, for all its power, is a predictable threat. You know where carriers go. You know what attack vectors strike aircraft fly. You know the surface combatants must transit choke points to get close enough. Iran spent 30 years understanding that predictability and building a system optimized to exploit it. Marines aboard two amphibious assault ships are not predictable in the same way. They represent a decision that has not yet been made, and that unmade decision is itself a form of operational pressure no missile can generate. The strait is still closed, but the architecture holding it closed is now solving a problem it was not designed to solve. In military systems analysis, when a defensive system is forced to operate outside its design parameters, it does not fail immediately. It degrades, slowly, then faster. Gaps appear in coverage, response times lengthen. Coordination between layers breaks down under the friction of uncertain threat direction. What the Marines have introduced is not a solution. It is the condition that makes a solution possible. The Navy hammered the coast for 30 days and the system held. Now the system has to hold in two directions at once. With an adversary that is watching, learning, and waiting for the moment, the geometry creates an opening. That is not a threat to shout about. That is a quiet shift in the weight of the problem. The kind of shift that precedes outcomes. If you want to understand why military campaigns are decided by systems and geometry long before the final engagement, subscribe. We break down how these forces actually work, not what the headlines say happen, but why the architecture of the problem made it inevitable.